Hello, welcome to Astronautics for Exploit. This is Dr. Ayoshola Ogunele. Spacecraft in-orbit servicing and approaches. Disruptive and innovative approaches for in-orbit repair, manufacturing, and refueling. The focus points are as follows. Spacecraft in-orbit servicing approaches and spacecraft in-orbit servicing. Spacecraft in-orbit servicing, a disruptive and innovative approach for in-orbit repair, in-orbit manufacturing, life extension, inspection, active debris removal, and spacecraft in-orbit refueling, has been envisioned for a long period of time to guarantee return on investment. Based on the decrease in the cost of launching commercial satellites and the rise of low orbit rather than geostationary satellites, for which servicing costs are less, there is an astronomical increase in the design and development of in-orbit servicing techniques and high commercial interest. In-orbit servicing, a new frontier of space services, involves autonomous or telerobotic servicing of a spacecraft. This could be achieved either via robotic spacecraft or by human astronauts. For example, as in the case of servicing of the International Space Station. For several decades, various in-orbit servicing approaches have been proposed and demonstrated. Examples are spacecraft deorbiting and reorbiting, spacecraft relocation and deployment, orbit and positioning maneuvers, spacecraft recycling and salvaging, station keeping and inspection of active satellites, in-orbit assembly and unit delivery, spacecraft refueling, debris removal, and a host of others. Presently, expired rockets and defunct satellites that became space debris are a serious issue for companies and organizations planning to launch mega constellations, particularly in the low Earth orbit. As a result, private space companies and government space agencies are developing spacecraft deorbiting techniques to drag satellites to the graveyard orbit and in the process help to minimize the risk of space debris. Spacecraft in-orbit servicing. In-orbit servicing is the new frontier of space services. It involves refueling or repairing of spacecraft while in orbit. New commercial interest in on-orbit servicing of spacecraft is due to the decrease in cost of launching commercial satellites and the rise of low orbit rather than geostationary satellite for which servicing costs are much less. Artist depiction of MEV-1 spacecraft attached to a customer satellite and performing its role in extending its operational life is shown in this picture. Spacecraft in-orbit servicing is referred to as autonomous or telerobotic servicing of a satellite by robotic spacecraft servicing that occurs by human astronauts, such as repeated and regular servicing of the International Space Station. Satellites using electrodynamic theater moving through the Earth's magnetic field create drag force, which could eventually deorbit the satellite. Artist's concept of on-orbit servicing, assembly and manufacturing one approaching Launcher 7 is shown in this picture. There are various spacecraft in-orbit servicing techniques and approaches, and some of them are spacecraft deorbiting and reorbiting, spacecraft relocation and deployment, orbit and positioning maneuvers, spacecraft recycling and salvaging, station keeping and inspection of active satellites, in-orbit assembly and unit delivery, spacecraft refueling, in-orbit manufacturing, spacecraft repair, and debris removal. Spacecraft deorbiting and reorbiting. Defunct satellites are becoming a serious issue for companies and organizations which plan to launch constellations that are of mega in nature. Spacecraft deorbiting technologies they are developed in order to send satellites which are expired into symmetry, or graveyard orbit. Debris removal demonstration capturing 8,000 kg envisaged environmental monitoring satellite is shown in this picture. The potential for widespread space debris could, if substantial enough in the relevant orbits, have an impact on space stations or satellite services and future launches. Due to the inherent problem of space debris, there are ongoing policy measures to establish the importance of mitigating and removing space debris. The picture here shows lithium-ion battery deorbital, which will activate timing runaway in a controlled manner. Deorbiting systems can be divided into passive and active systems. Passive systems are generally integrated on board a spacecraft, and when the satellite reaches the end of life, part of its mission cycle, act as a drag-causing system to help move the satellite into the graveyard orbit, while active systems revert to external deorbiting services or products specifically designed to move satellites in the graveyard orbit. Various examples of deorbiting systems are article deorbiting systems, deployable drag sail deorbit subsystem, and deployable drag sail deorbit subsystem. N. Illustration of spacecraft deorbiting service is shown in this system. Spacecraft relocation and deployment is another important approach of in-orbit servicing. Satellite relocation refers to the process of repositioning a satellite in orbit without using fuel, typically by extending a mass on the end of a tether. Satellite relocation can be used for various purposes, such as correcting perturbations in the satellite's orbit, adding energy to the orbit for boosting an orbital transfer, and powering the satellite during eclipse by using the tether for energy storage. Illustration of spacecraft life extension approach is shown in this picture. The relocation of frequencies in a communication system can be considered a form of satellite relocation where vacant bands are searched for and communication lines are moved to fill these bands. In the context of nanosatellites, satellite relocation can involve adjusting the center of mass of the spacecraft so as to reduce external disturbing torques and improve altitude stability. Spacecraft deployment refers to the process of moving a spacecraft out of the launch vehicle and into the right orbit or trajectory, from one orbit to another orbit, or from a point in an orbit to another point in the same orbit. Relocation of Soyuz spacecraft to new space station parking spot service is shown in this picture. Spacecraft orbit and positioning maneuver is another technique of in-orbit servicing. An orbital maneuver is a carefully planned and executed adjustment made to a satellite's orbit in space. This maneuver is typically achieved by using various propulsion systems, such as onboard thrusters or engines, or by taking advantage of gravitational assist from other celestial bodies. The primary objective of an orbital maneuver is to modify specific orbital parameters of the satellites, such as its altitude, inclination, eccentricity, or orbital period, in order to achieve certain mission objectives or operational requirements. An artist's impression of how clean space servicing spacecraft will approach a spacecraft in geostationary orbit to latch on and provide orbit control is shown in this picture. Station keeping and inspection of active satellites is another aspect of in-orbit servicing. As space becomes increasingly congested with both active satellites and space debris, the risk of potential collisions and subsequent damage rises. Routine inspections ensure the structural integrity of space assets and can provide early detection of minor damages before they escalate into critical failures. By identifying potential vulnerabilities and areas of wear and tear, operators can make informed decisions about satellite life extension, repurposing, or deorbiting, thereby enhancing the sustainability and safety of space operations. Illustration of in-space inspection system is shown in this picture. In-space inspection of satellites and other space assets is carried out in order to solve multiple challenges. One of the primary problems this resolves is the issue of malfunctions or anomalies in satellites post-deployment. Inspection services can provide real-time detailed visuals and diagnostics of the spacecraft exterior, aiding in understanding of unexpected behaviors or performance drops. Illustration of spacecraft in-space inspection approach is shown in this picture. Spacecraft recycling and salvaging is another approach of in-orbit servicing. Recycling resources in a spacecraft is necessary due to the limited availability of supplies. Water is a key example of a recycled resource on spacecraft like International Space Station, and this ensures that astronauts have sufficient drinking water without adding extra weight to bring more from the Earth. By repairing, repurposing, or recycling satellites and space trash at a facility in Earth's orbit, the space trash may be utilized to build future spacecraft or exploration outposts, such as a base on the Moon. The picture here shows illustration of robots that could recycle dead satellites in orbit. Using what is already in orbit minimizes the need for a launch while also reducing space debris. Satellite recycling might provide not only raw materials for more space construction, but also a source of revenue to help fund it. Different proposals have been put forward to salvage and repurpose relic spacecraft. Salvage and debris cleanup is very difficult. Removal of inactive man-made debris from outer space and the salvage of valuable spacecraft hardware involve legal problems. Think orbital design platform for in-space manufacturing and debris removal is shown in this picture. In-orbit assembly and unit delivery is another approach of in-orbit servicing. Government space agencies and private space companies are developing robotic technologies to autonomously manufacture and assemble hardware, components, and tools in space. Additive manufacturing, which refers to a 3D printing, can build and assemble complex components in space, deliver on-demand hardware, and allow for structures larger than current rockets can deliver and deploy to orbit. Illustration of on-orbit assembly is shown in this picture. Spacecraft refueling is another important aspect of in-orbit servicing. Spacecraft are limited to one tank of fuel. This puts unnecessary burdens on mission planning, design choices, and finances. Spacecraft refueling is the operation of replenishing onboard propellants and other consumables in satellites in orbit. For example, in geostationary orbit around the Earth, this could be for storable propellants and for cryogenic propellants. Illustration of Northrop Grumman satellite refueling technology is shown in this picture. In-orbit manufacturing is another important in-orbit servicing approach. In-space manufacturing or in-orbit manufacturing is the fabrication, assembly, or integration of tangible goods beyond Earth's atmosphere. In-orbit manufacturing process is executed either by humans or automated systems by taking advantage of the unique characteristics of space. A vision of a future moon base is shown in this picture. Three major domains of in-space manufacturing are in-space manufacturing for space for space, where goods with improved properties produced in outer space microgravity are transported back to the Earth. And also in-orbit space manufacturing for service, where goods are produced on or sent to services of celestial bodies like the Moon, Mars, and asteroids. Illustration of a manufacturing platform in low Earth orbit is shown in this picture. In-space manufacturing uses processes such as additive manufacturing, printing a 3D object in successive layers, subtractive manufacturing, making 3D objects by successively removing material from a solid, hybrid manufacturing, combining additive manufacturing and subtractive manufacturing, and welding, joining together pieces of material. Novel orbital and moon manufacturing materials and mass efficient design program is shown in this picture. Spacecraft repair is another in-orbit servicing technique. Presently, researchers are designing robots that can repair satellites while both are still in orbit. The repair robot will have to meet the broken satellite in space at the paved speed in order to ensure there's no chance of collision. Then a robotic hand will need to deftly repair the satellite issue. Illustration of Northrop Grumman's robotic satellite repair spacecraft is shown in this picture. Think Orbital is designing and developing satellite design toolkit with X-ray fusion. It plans to demonstrate a robotic arm in space equipped with a weighted gun that could be used to repair and take X-ray images of satellites. The planned demonstration is part of the Think Orbital's broader vision in order to provide an array of tools and facilities for repairing and maintaining spacecraft in orbit. Illustration of Think Orbital's toolkit for in-orbit repairs and manufacturing is shown in this picture. Debris removal is another important approach. Several technological efforts are being undertaken to limit debris, and it includes making reusable rockets and maneuverable satellites. International Space Station performed an in-orbit maneuver to dodge debris. To meet the needs of cleanup, industries have developed debris cleaning technology like ground laser nudges, space tugs, and space lasers. SSE, the orbit mission, which is developing technology to capture envisat in orbit using a robotic arm or net, is shown in this picture. For more information, contact Astronautics for Experts. You've been listening to the presentation on spacecraft in-orbit servicing and approaches, disruptive and innovative approach for in-orbit repair, manufacturing and refueling, presented by Dr. Ayansola Ogundele, with the focus points spacecraft in-orbit servicing approaches and spacecraft in-orbit servicing. Thank you.